spent the last couple of months working on a SIMH simulated HP 1000, and I would like to create some documentation on how I navigate and use this system, and I really don't want to write it down, so I'm just going to do a quick and dirty video of just some of the basic navigation and how to create, compile, link a Fortran program, how to edit it with Edit 1000, and just a couple of other simple things. On the HP 1000, the two primary websites that you would want to refer to are this one, bitsavers.org. This contains a bunch of software for the HP 1000. It also contains quite a few manuals. This didn't end up being my primary reference, but it does have a lot of good stuff in it. My primary source is the HP Computer Museum, and this actually contains the RTE-6. So this is the operating system. I'm in the wrong place here. RTE-6. Nope. Anyway, oh, there we go, hardware, RTE-6. Huh, why am I not finding this? Software, RTE-6. There we go, sorry about that. Starting off on a bad foot already. So anyway, this is the basis for the RTE-6 operating system that I'm using. I generated everything from this. And so if you look at the bottom, you can download it directly from here, or if you go to my blog at bigdansblog.wordpress.com, then you can get the same stuff directly. One thing to note, if you decide to do this, they will mention in here that you need to convert the endian of the bytes. So you have to do this DD command against the disk drive that you give you if you want to use their software. The stuff that I've got, this has already been done for you. So that's where the operating system came from. And then if you go to their documents, RTE-6, here are pretty much every manual that you would need for RTE. There's a couple things like I don't think the Fortran manual is here, but if you go looking for it elsewhere, like it might be in RTE-4, but pretty much like the editor is in here, system manager, most of the manuals ended up being in here. There's really not too many useful manuals on BitSavers for the HP 1000. So again, I would just go to my blog post and download the HP 1000 Adventure SIMH files. That will make this a little bit easier, and that is actually what I'm going to be using for this little demo. If you take a look at the files that come with that, the simulator itself is this HP 2100. The configuration file that it boots from is this .sim file. I have a bat file that will execute everything for you automatically, and then the HP 1000's hard disk is emulated right here. And if I take a look at HP1000.bat, you see in order to start the simulator, it just runs HP 2100 and then runs the that file. And if I take a look at that, so inside of here, the things that you would find interesting here are the BACI port. So this is the terminal card, and this is the TCP address of the terminal card. The rest of this really isn't going to help you too much, but that will. So we're going to go ahead and start the simulator here. And when it starts up, it will actually tell you up here too that it's listening on port 1050. It'll tell you the devices that are configured in. It's got a mag tape. It's got a paper tape reader or paper tape punch. It says it's got a line printer. The hardware is configured, but the operating system does not know about that. And then the BACI is the terminal emulator. So we're up and running. If I hit the enter key, it will give you this prompt. This is the console prompt for the HP 1000. There's not a whole heck of a lot that you can do with that. Also, if you type Control-E, that brings up the SIMH prompt. And this is where you would type in SIMH commands, such as if I want to attach a paper tape to the paper tape reader, I'd use the attach or detach. The nice thing about SCP is if you do a Control-E and bring up this prompt, the simulator is still running. If you got a terminal connected through the BACI, it does not affect it. And all you got to do is hit return, and you're now back. You can do a control break, and if you do that, it's going to stop the simulator. You can type in all the same commands. So I can do a show div on either one of them. But the nice thing about doing it this way is if I hit an up arrow, I can see the commands, and I can go back and retype commands. So if I've got to do a whole bunch of commands, then I will use control break and get into the SIMH or the SIM prompt. Otherwise, I will just do a Control-E. And at this point, to get out of SIMH and get back into the simulation, you just do G for go. And so I am back to the HP 1000 prompt. On the HP 1000, there's just a couple of commands. And notice, if I type in a command, just type in a BS command, you have to type an enter to get that prompt back. Or you have to type something. It could be enter, it could be X, but until you see the prompt, it's not actually prompting you. And then the reality is there's pretty much nothing that you can do with this prompt. Oh, I should mention to edit backspace. And if you want to delete the entire line, it's control backspace. And that works both at the console and at the command interpreter prompt, which we're going to get to shortly here. About the only thing really interesting in the editor is you can see what's running by running the what's that program. So RU is run, comma, and then the program you want to run. Very few programs that run this way. What's that is one of the few that I can find. The only other thing that I really ever use console for is if I get a program hung on the BACI, then you would type OF, comma, and then the program name to abort that program. But that's a pretty rare thing. Typically the thing people would normally do is they would just immediately run FMGR. This is the file manager, and the file manager is the original way that the HP 1000 was used to manipulate files. And it's very odd compared to any modern computer system. They worked on the concept of disk cartridges, which is a weird concept because, I mean, you could put a disk pack on this thing and then split it up into a whole bunch of cartridges. And the cartridges could be system cartridges or they could be assigned to specific users. So it was just a kind of a way to segment the system as we do with directories now, but this is late 60s, very early 70s. The idea of directories probably didn't really exist anywhere. In the file manager, Again, honestly, there's not much that you would want to do here because the command interpreter in the new file system will do about everything. But if you wanted to mess with disk cartridges, this is where you would do it at. If you type in CL for cartridge list, that will show you the disk cartridges. So I have a couple of logical units with disk cartridges on them. And then this is the cartridge name over here. Cartridge 2 happens to be the system cartridge. This is an HP cartridge. That's a scratch volume. And LU15 is where the modern file system with all the subdirectories are at. And you'll notice, so last track tells you how big these are. And this is quite large. They've assigned almost all the space to the modern file system, which is about what you would expect. If you do a DL, HP, so this is the HP cartridge. If I type in DL HP, it will show you all of the files on that particular cartridge. And these files just happen to be the Fortran 77 compiler. One thing about the files on cartridges, you got 6 characters for the file name, but you did get to use special characters in the file name. And there was a convention as to what these special characters meant. For example, % tended to be a relocatable file. The quote indicated it was an ASCII file. And in fact, if I recall correctly, this is the install document for the Fortran compiler. If you just want to see every file on every cartridge, just type in DL, and there is everything. So again, there's not a whole lot to be done with the file manager. So we're going to go ahead and exit out of that. At the console, you can get into the FMP file space, which is a command interpreter file space. And to do that, you type in EN for enable, and then RT for, RT is a password, so it's enable, password. And when I do that, I got to hit another enter to get it to give you the login prompt. And the user is, there's only one user, manager.sys, password is HP. And this is the command interpreter for the modern directory, subdirectory-based file system. Once you do this, just a warning, you cannot get back to the console prompt. Probably no reason for you to want to get back to the console prompt, but you can't. The only way to get back at this point is you would want to exit the command interpreter. And the manual does make a point of saying you need to exit the command interpreter to make sure the file system is properly closed. And then you're going to get into the SIMH program and then quit it. And that's how you would get out of the command interpreter prompt from there. So we're going to go ahead and start it back up. We're going to leave this in console mode. And so what we really want to do is we don't want to use the console even in CI mode. We don't really want to use it because the HP 1000 was designed to use an HP terminal, which means you need to use an HP terminal emulator. It is sending control escape sequences to the terminal that this cannot interpret. If you're used to using old terminals, you probably are familiar with like the VT52, VT100 standard. That was DEC standard, which ended up being used by many other manufacturers. Well, HP had their own standard, and they did not use the DEC standard, so you have to use an HP terminal emulator. The terminal emulator that is free is called QCterm, and let's clear the screen, clear display. If you go to my blog post on the HP 1000, I'll tell you where to get this. It's in the Net Museum, or the hpmuseum.net, and that'll just tell you exactly where it's at. And then we'll also walk you through the configuration of it, because there are a couple of things you need to do to get this to correctly connect to the HP 1000, which I will go through with you here. Once this is running, first thing you need to do is go into the connection settings. And you want to make sure that your port matches the BACI port, which is 1050, and it does. And the host name is just going to be typically 127.0.0.1, which is the PC you're running on. So we're going to click OK. And as soon as we do that, we're connected in. Again, password is HP. A couple things I would suggest you do is, I highly suggest that you turn on transmit control characters to host. If you turn this off, for example, if I go to, you can use Control A to select, Control C to copy, Control V to paste. Basically, all these control keys are being used by the terminal emulator. But the HP 1000 really wants a whole bunch of different control characters. And so the best thing to do is just do not allow the terminal emulator to process control characters. So you want to turn transmit control characters to host. And then if you need to do something like go home or clear display, you're just going to have to use the menu to do it. It's a little clumsy. If you happen to be lucky enough to have the old HP, the Reflections terminal emulator, then it works a little smoother with this. But this is free and actually works pretty well. So anyway, again, you want to make sure transmit control character is off. And then preferences, I suggest that you turn on caps only mode. There are a few situations in the HP 1000 where it does not like lowercase characters. And off the top of my head, I can't remember where they are, but it can be a little confusing as to why things aren't working, and it's just because it doesn't know what you're typing. And I like to use the block cursor in this particular instance, because if the align cursor gets down at the very bottom here, it disappears underneath that label, and you can't tell exactly where the cursor is at. So it just makes it a little less awkward. So that is everything you need to know about QCterm. All right, so now we're going to take a quick look at the command interpreter. So as I said, this is kind of like the Linux shell. Very, very primitive, but at least the file system is what you would expect. So the DL command is how you list things. If I type in DL slash, oh, by the way, because I haven't changed my directory yet, it's actually in a weird directory where it can see the cartridges. So normally you're really never going to want to do that, but that's where it's at. That's why you see that. So if I take a look at the root directory, it's going to show what's in the root directory. And the only thing that can be in the root directory on this are other directories, and they are actually files with a dir extension. Like I have an admin directory, I have a scratch directory, I got a temp directory. So I want to go to the temp directory. And let's make sure there's nothing in here. Clean that up to get started. Okay, so let's just create a dummy file called test. CR is the create command. As I said, if I type in the directory, it works like you would expect, or if I just type in DL test. The thing that's a little weird about the file naming on this, the nice thing about the command interpreter file system is you get to use long names. I think it can be 16 total, and you get an extension. So, I could say CR test text if I wanted to. But it also allows you to access things on the disk cartridges too, and it also gives you the ability to manipulate some of the characteristics of a file. So as I mentioned, if I do a DL/temp test, that's one way to look at the directory. Or I can do the old way where I say I want the directory there. So this is the old cartridge way of doing things. And as I mentioned, you can specify characteristics of a file the same way. So if I create a file called test2, I can say that it's of type 4, which indicates it's some sort of compiler source program. And then I can say that I only want to allocate one block. And on the HP 1000, one block is 120 words or 256 bytes. Now, if I take a look at the file, test2, and the exclamation point indicates that I want to know everything that you can tell me about this file. So test2 is type 4, one block. And there's no records in it right now. The other thing that you can do is I can say I want to take a look at the cartridge HP. The other thing that's useful in the DL command is if you're trying to find a file in a subdirectory and you don't know where it's at, you just use wildcards for the file. In this case, @ is a wildcard, not an asterisk. I'm going to look for a file called snap. And then if I use this thing called a mask qualifier.s, and that tells it to go looking through all the subdirectories. So in the system subdirectory, it found the snap.snmp file. All right, so the cr command is one way to create a file, but it is honestly really not the way one would create files. In fact, let's go ahead and get rid of everything we've done so far. Another way to create a file is just copy from your terminal into it. So the logical unit for my terminal is 1, and I want to create a Fortran file called test.ftn. So normally it's really all you need to do, but if I want to force it to be of type 4, indicating it is a source program, I can force the type that way. You really don't have to do that, but if you want to be consistent with the other source programs, then that's how you would do it. All right, so it's ready to accept the program from your terminal. I'm just going to copy and paste that from here. And so there is a little hello world program. After you've typed everything in, you need to do a Control-D to indicate that you're done. And by the way, Fortran 77, which is what this is a column-oriented language. Columns 1 through 6 had special characters in those had special meanings. For example, a C in column 1 indicates it's a comment. The actual text would start on column 7. That's why there's blank spaces there. So there is a little, very simple Fortran program. So now we're going to compile that. To invoke the compiler, you use the ftn7x command, and then you tell it the source file. You tell it where you want the listing to go, and then you tell it where you want the relocatable binary to go. Yay, it worked. And now if I take a look at test.lst, notice I'm using li for list. There is the compiler output. So now what we need to do is link that relocatable module into an executable program. That's done with linker. Type in link, and then you're going to say I want to relocate test.rel, and then we just exit, and it will create the program test.run, which is the executable program. Now if I type test, hello world, yay. All right, so obviously this is a tiny file. Trying to edit it, trying to edit that file is not that big of a deal. But if we have a big file, we really need to use the real editor, which is edit 1000. So look at the notes here. First thing we're going to do is we're just going to use edit 1000 to build just a really simple file so you can see how to create a file. We're going to edit a file called fname. Doesn't exist. So it comes up, knows it doesn't exist. And then if I want to put in text, I'm going to say insert and the text that I want. And then if I type in the W command, which we'll talk about in a second, that will show you the file. Now, to save that file, I'm going to do an ER for exit and replace, and that will save that text into that file name. Or I can type in A for abort and just lose my changes. I really don't need those changes, so we'll go ahead and abort. Instead, we're going to work on a much bigger file so that I can show you how to navigate with this thing. So we're going to copy one of the adventure program files over. So CO is the copy command. We're copying out of the admin directory. There's the file name, and the sign is a mask saying just use that same file name. Now if I do a DL command, there it is. And just for the heck of it, the PU command is purge, and I want to get rid of everything that is test. So I'm going to say purge test.all. And it's going to ask you for every file, do I want to get rid of it? I can say yes to get rid of it. I can say no to not, A to just quit out, or to abort the whole delete, or S is stop asking me and just go ahead and do it for the rest of them. So now we're just left with the adventure file. So we're going to edit that, adv01.ftn. So inside of edit 1000, this is not the worst text editor I've ever seen, but it is not an easy editor either. None of these character mode editors were ever particularly easy to use compared to what we're used to these days, especially. To get help, you would just type in question mark, and it will show you the commands. If you want to know about a particular command, like say I want to know about abort, it is comma A. Let me make sure I'm not lying. Oh, I swear that I tried skipping the comma and it didn't like it, but question mark A works. So there is information about the abort command. Some of the navigation stuff, if you just type in dot, that will print the current line. If you type in N, that's going to tell you the number of the current line. If you type in $, that's going to say go to the last line. If I type in M, the last line is 268. If I type in 1, that means go to the first line. And again, that is line 1. Now, if I type LN, that's going to show the current line through the next 20 lines. If I type LN again, actually, the first time I type LN, that's the last time I need to do it. If I just type in L now, what the L does is it shows lines numbered, or the LN shows lines numbered, and L just says, hey, he said do it numbered, so from this point forward, I'm going to do it numbered. If I do LU, that means show the lines unnumbered. And once I do LU once, then L is going to continue following whichever I requested. And I tend to want to see numbers, so I do LN. If I do LN50, it's going to show the first or the current line through the next 50 lines. If I do W, so my current line is 183. If I don't do the W command, that means show me a window around the current line, which is 183. So there's 183, and it shows you, I believe it's previous 10 and the next 10 lines. Now, the one downside to using line numbers is notice how it wraps here. If that's a problem for you, then do actually, I think Win always does. Yeah, Win always shows the line numbers. So, so now let's go back to line 1. If I want to find something, it's the F command. And I am going to find the word adcom. Now if I type W, there's adcom. It's my block data. It's on line 202. Now if I type K, it is going to delete the current line, which that little pointer indicates 202 is the current line. If I do a W, the block line is, or the block data is gone. If I do an undo in a window, block data is back. So that's how you kill a line, and then if you need to undo your last command. So actually editing text inside of the character mode of this is really cumbersome. You really don't want to do that, which is why you want to get QC term running, because we're going to actually use what HP would have called block mode in order to edit text. And in block mode, basically displays a buffer of data to your terminal. You work on the buffer of data, and then you post the buffer back to the computer, and it updates the text file from what was on your terminal. So to get into screen mode, as it's called, S is the command, and we're actually going to want to start on line 1, so we're going to do 1S. So the first thing you will notice here is this header and this trailer down here, or footer. Do not modify anything on those two lines. If you do, when it reads the screen buffer back in, it knows the data that you've been modifying is between these two lines. And if you accidentally mess these up, then it just has a cow. And typically, when I've messed those lines up, I just end up losing all the changes. I've never figured out a way to correct making that mistake. And for the most part, I don't mess those up. The only time I do it is if I'm adding new text to the bottom of a file. Like, if I add 5 lines, I might only insert 3, not thinking. And I'm busy typing, looking at the source code, and I'll accidentally overlay this. And when I do that, I know all is lost, and I just have to abort out and do it again. So that's what those two lines are. There are various control commands that you can use in order to navigate through the file. And every control command has 2 formats. Either it is the control command, such as Control F for forward, or it's Control F for forward. The difference is if I just do one control character, that means save the screen and then do the navigation. So Control F would mean save all the changes that I've made on that screen and then go forward a screen. Control P is going to save all the changes on that screen and then go back a screen. If you just want to quickly space forward through stuff and you don't, the biggest problem I have is if I'm looking through a file, if I accidentally type a key, I don't know that I've done it. And so that's why it's really useful to have the double control versions of these. So if I'm looking through a file, I'm always doing Control F, enter, Control F, enter, or Control P, enter. Only when I make a change am I going to do a Control F or a Control P. Honestly, if I'm making a change, I'm probably not going to do either one of those. I'm probably going to just tell it, hey, save those changes. So we'll talk about that in a second. Once I'm on a chain or on a screen that I want to modify, the cursor keys do what you would expect. It's an overwrite mode by default, so if I just start typing in characters, it's going to overwrite. And remember that I set this to be uppercase only, so there's no way for me, short of going back up and altering the terminal configuration, to get this to be lowercase. And honestly, there's very few places in this where the text is lowercase. So it's not really been much of an issue. If you want to insert text, you would hit the insert key, and notice that the cursor is going to change when I do that. And then if I type, I'm inserting. Turn insert off. It is a little disconcerting for insert to be off by default, because more than a few times I get into a screen and I start typing because I'm so used to insert being on, and I overwrite a line that I did not mean to overwrite. And then the only way for me to recover from that is to exit out without saving the screen, because typically I have no idea what I just overwrote. And there's no way to force it to be in insert mode when it first starts. To get rid of text, I'm just going to do delete character. If I need to insert a new line, it would be Control Insert. To delete a line, it's Control Delete. And this is where if I wanted to type in a whole bunch of text at the end, I'm going to insert a bunch of lines. And notice, even though it appears that went off the screen, it did not. And so I can come down here and I can type in a bunch of stuff. And when I start getting close to this line, then I'll start inserting a bunch more. How many of these lines can you do? Don't really know. I don't try to push it. Typically, probably that's about as much as I'm going to try. Maybe another 5 max, because I don't know at what point it's not going to be able to read that back in properly. And the last thing I want to do is lose text that I've been entering, so I've not messed with it. So again, delete that. We're going to do that. Let's get back up to the top here. So, as I mentioned, there's a way to save these changes, and this is it, Control U. So recall I made changes here. Well, I don't actually want to save these. So if I do a Control U is going to read the screen and then save the changes. Control U is just going to abort out. So if I do Control U, Enter, and I'm back in screen mode, I type in S, and I have not lost that change there. See what else we got here. Talked about that again. So Control F, oops. You might have just noticed that kind of read down. So that was it reading the buffer. Let's do that one more time. When I hit enter, it's going to read the buffer. If I do Control F, it doesn't read the buffer. It just does it. Again, Control P. If I do just one Control P, it reads the buffer. The terminal buffer, that is. If I wanted this particular line to be at the top, Control T or Control T, Control T. And I want to, because I don't want to save the buffer. That moves that up to the top. If I need to get to the end of a line, I can do Control Z. And I don't, for the most part, I'm going to double everything. If I'm not going to use double control characters, I'll let you know. But Control Z to get to the end. Control A to get to the beginning. And then there's one other somewhat weird command. Notice it's telling me top is line 66, bottom is line 86. If I do a Control XX, enter, top line is 82, bottom line is 181. So it has read 100 lines into the buffer here. So that gives you more room to take a look at stuff, move around, and edit the buffer. So honestly, I haven't used that very much. But it's there. So now let's get out. Control U to get out. I'm going to go back to the beginning again. Let's go forward one more time. All right, this is an okay place. If I wanted to join the implicit line and the logical line together, then I just do a Control J, enter. And that'll bring the two together. Splitting those is a little weird. It's an escape 4, Control B, enter. Still have to clean up some stuff, but that will split it. So again, that's escape 4, Control B. How they got that, I don't know, but it does work. And then the last thing, if I wanted to go to the beginning and not exit out of this, there is a command, Control C, Control C. When I do that, I'm now in line mode. Even though I can see the screen mode, right now I'm functioning in line mode. And in fact, I could, if I knew what the line mode commands were, I could alter this line if I wanted to. It's so much easier to screen mode. I never memorized how line mode works for that. But it is useful if I want to go back to the beginning, just do 1. Or if I want to go to the end, Control C, and go to $. That gets me back to the end. Let's go back to the beginning again. If I want to find a line, Control C, and now find ADCOM. There you go. And so that lets you navigate while you're in screen mode just a little bit easier. So that's pretty much the stuff you really need to know about Edit 1000. So we're going to get out of this, Control U, and abort. There's a couple of utility commands that are useful to know. One is LUPRN, so that prints out the logical units, gives you a nice little table of the devices on this computer system. From you as a user's perspective, you're actually using the session logical unit. So for me, logical unit 1 is the BACI card. So remember I did a copy from device 1 to a file name. There's where that 1 came from. The other devices that you would care about are the paper tape punch is device 4, paper tape reader is device 5, and then the mag tape is device 8. And I'm going to show you in a second how to use the paper tape punch. But before I do that, let's take a quick look at the only other command. It's the same one we did at the console. Was that shows you what's running. I believe oh, sorry, never mind. I was thinking you could do an off command in CI, but you can't. All right, so the last thing that I want to talk about is how to access devices. You can copy and paste fairly large amounts of ASCII data through QC term. You can't do anything binary that way. But if you're going to move a lot of data, you probably just want to use paper tape reader or punch. And so what I'm going to do is I'm going to show you how to punch this to paper tape. And the reason you do that is there is no paper tape, obviously. The paper tape is just a disk file that you can access with your PC. So what we're going to do is we are going to go back to the simulator console window, and we're going to attach to the paper tape punch a new file called adv.papertape. You don't really need to use this -n if it is truly a new file, but I've found if this file exists and you type it, attach it to paper tape punch, you would assume like, hey man, I'm writing to a paper tape, like give me a new file. It doesn't do that. Instead, it overwrites the old data. So if I wrote, say, 100 bytes to the file, and then I reattach it and only write 10 bytes, first 10 bytes will be the new data, and then you have another 90 bytes of the old data, and that is just going to cause you problems. So I've learned, like, anytime I'm going to write, I do a -n. Anytime I'm going to read, I do a -r. So anyway, we have attached a file called adv.ptape to the paper tape punch. Then we're going to come down here, and we are going to copy adv01.ftn to the paper tape punch, which is device 4, as we saw in the LUPRN program. And voila, it has copied it. So now that we've copied it to the file, the physical file, what we need to do is, by the way, I'm doing a Control-E here. That's how I'm getting into the SIMH SCP prompt. So we're going to now detach paper tape file from the paper tape punch. And if I take a look at, there is the paper tape file. And if I do a tape, oh, that's right, sorry. This is the file we just created, adv.ptape. More, adv.ptape. And there is the ASCII file. You can read back in the same way. You would just attach an ASCII file to the paper tape reader. You can write binary files to the paper tape reader, or the paper tape punch just fine. I've had no problems with that. However, for reasons that I do not understand, you cannot read a binary file on the paper tape reader. It just does not work. It alters the data as it's reading it in. And essentially, every time it sees a new line character, it writes a couple of extra bytes or something. I forget exactly what it does, but it corrupts the data. The other thing you can do is you can read and write mag tapes. I'm not going to go over that. That's covered in my blog post. It's a lot easier to take a look at that because it's way more involved on being able to read and write mag tapes, because you're going to have to go through some utilities to convert those into the SIMH tape format. So that is pretty much my brain dump on how to use an HP 1000.